In today's lesson, we will be looking for patterns in the binomial factors and their products. Here we have three binomial factors. We have x plus 3 squared, then we have x minus 2 squared, and x plus 4 squared. If we take our two factors and we write them out, because as you recall, if things that are squared just means that they're multiplied by themselves. So in the first one where we have x plus 3 squared, we rewrite this as x plus 3 times x plus 3. And then in the second two binomial factors, we have x minus 2 times x minus 2. And in the third one, we have 2x plus 4 and 2x plus 4. So again, we're going to take these and we're going to look at their factors and see what they have in common. And then in the end, we want to look at their solutions or their products and see what those products have in common in comparison to their factors. If we look here, we notice that all three of these are being multiplied by themselves. So what we want to discover is what happens when you multiply a binomial by itself. In order to do this, the first thing we need to do is look at what it looks like when we FOIL it out. So on this third row of each of these factors that are multiplied, we FOIL them out and we are going to get an expression. And if you look at this expression, you can see that the two middle terms are exactly the same. You can also see that the first term is x squared, and in the second expression it's also an x squared, but in the third one it's a 4x squared. Look at this first term, and then look at the original binomial and see if you can see a relationship between those two. You should be able to see that x squared is simply this first term squared. And here we have our first term, and it's also squared. And here we have 2x, but if we square 2x, we get 4x squared. If we look at our last term, is there a relationship between our last term and the term that is the last term of the answer? If we look here, the first one, we have a 9. Our very last term of our original binomial was a 3. What is the relationship between 3 and 9? You should be able to see that if you square 3, you will get 9. So 9 is that second term squared. In the second expression, we have 4 as our last term. And again, if we look back at our original binomial, the last term was a 2. You could say it was a -2. -2 squared gives us 4. In the third expression, we have 4, and if we square 4, we get positive 16. By looking at this third step, we can see that the first term in our what's going to be our answer is basically the first term of the binomial squared. And the last term in our final answer is basically the last term of the binomial squared. The middle terms, if we look at those, we can see that they're exactly the same. And we can also see that if we multiply these, the two terms together in the binomial, we're going to get that middle term. X times 3 is 3x. And again, that middle term is repeated. -2 times x is -2. And again, it's repeated. 4 times 2x is going to be 8x. And again, it is repeated. Now, like with all expressions, we need to combine our like terms. So we're going to go ahead and do that. And here we're going to have our final answer. If we were to multiply x plus 3 times x plus 3, we're going to get x squared plus 6x plus 9. And if we multiply x minus 2 times x minus 2, we will get x squared minus 4x plus 4. And if we multiply 2x plus 4x plus 4, we're going to get 4x squared plus 16x plus 16. Now again, let's look at the final answer in our original binomial and see if we can see the relationship. Our first term, x squared, is simply the first term of the binomial squared. And our last term is simply the last term of the original binomial squared. The middle term then, how did we get the middle term? Well, the middle term are the two terms multiplied together and then basically doubled because, as you recall, in the middle of that equation, you just have them twice. And let's look at this next one to see if that's the same for here. We have x squared, which our beginning term was x, so if we square that, we get x squared. Our last term is negative 2. If we square negative 2, we'll get our last term in our answer. And then we have the middle term, which is negative 4x. Negative 4x is simply x times negative 2, and then we double that and we get negative 4x. Look at the third expression and see if you have the exact same thing, if the terms are made up the same. Is that first term in that equation simply, or in the expression, simply the first term of the binomial squared? Is the last term in the expression the last term of the binomial squared? And that middle term in that final answer, is that just the two multiplied together and doubled? You should be able to say yes to all of those. So when we multiply a binomial times itself, we're going to get this particular pattern within our answer. This helps us when we see these, when we're multiplying, and if we don't want to FOIL them, we remember our pattern, it makes that finding that answer much easier. Let's look at two more kinds of binomials. Here we have three binomials that are being multiplied together, or there are three sets of binomials where two sets of binomials are being multiplied together. And the only difference is that one of the binomials will have a plus and the other will have a minus. And as you can see, that's the case for all of them. Again, in order to look at the pattern, we're going to need to FOIL them out. So if we were to FOIL these, we would find that we would have x squared plus 3x minus 3x minus 9. Now if we look at our first term in this FOIL on all three expressions, again, it's simply that first term squared. X squared, and here we have x, we square it, we get x squared. And in this third term, we have 5x, and if we square that, we'll get 25x squared. The middle term is the one that we want to concentrate mostly on in this one. The middle two terms here, I have a plus 3x and a minus 3x. In the second expression, I have a negative 4x plus a 4x. And in the third expression, I have a negative 5x plus a 5x. What's going to happen when I add those two middle terms together? You should be able to see that they will cancel out and you will get 0. So in all three of these terms, we're going to get 0 when we cancel them out. The last term, if we look at that, is basically the same as before. It's going to be that last term squared. So here we have a 9, which is 3 squared. And here we have a 16, which is 4 squared. And here we have a 1, which is 1 squared. The only difference here versus the other one, the other times we were looking at, is that all of these will have negative signs. The final answer will be a negative. So if we eliminate that middle section that cancels out to 0, we end up with that perfect square of the first term and the perfect square of the last term, and we put them together and we're going to get a binomial answer. Then if we take the we take the square of the first term and we put it together with the square of the second term, again, we're going to get a binomial answer. And that is the same for the third expression. 5x squared minus 1 is basically the first term squared and the last term squared. When you are multiplying two binomials together with the only difference between them is the plus and the minus, the terms inside of the parentheses are the same, then you are simply going to just square that first term, just square that last term, and then you're going to put a minus sign in between. And the reason that we can do this is because those middle terms will eventually cancel out when we FOIL those out. Looking at special types of multiplying binomials is a lot easier, makes your multiplication a lot easier. You don't always have to FOIL it out if you can see the pattern. And if you look for these particular types of multiplication problems, it just makes your multiplying very easy and it allows you to save a lot of time.